Welcome everybody, and thank you for joining yet another exciting webinar in our Xplained series. In today's 30-minute session, we will give a high-level overview of OT security and provide guidance on how to secure operational technology OT, while addressing the unique nature, performance, reliability, and safety requirements of these environments. As in all our Xplained sessions, the goal is to provide you with an overview of the basics to give you a head start to discover the concepts on your own. I am Bart Omblé, team lead of the business development managers at Exclusive Network. One of my main tasks is also being BDM for Fortinet, one of our biggest vendors. And because of their focus on IT, I will be your host today. The information given in this webinar will be, however, vendor agnostic. So let's have a quick look at today's agenda. I will start with briefly explaining OT, what OT or operational technology exactly is, followed by the difference between OT and IT. Next, we will see how, or rather why, OT security is needed and the different categories in which it can be divided. We will also briefly touch the directives, standards, and models that are common practice in OT environments. To finally wrap up this session with some starting points for OT security and some key takeaways. And please, do not hesitate to contact us if after attending this webinar you have any questions. Please consider sending us a message so we can set up a meeting or a one-to-one session. Also, a deep dive with one of our OT specialized vendors or one of our pre-sales engineers is possible if you have any specific requirements. To explain what OT and OT security is, I would like to present to you the Gartner definition. Operational technology is hardware and software that detects or cause a change through direct monitoring and or control of industrial equipment, assets, processes, and events. This definition was created by Gartner in 2006 and was at that point in time mainly used to describe the sensors and automated mechanisms in electrical power grids. So a relatively new term, but of course not a new concept. Industrial networks have been around for years. Of course, OT security contains the practices and technologies to protect OT, but these practices and technologies are now evolving into distinct categories to address the growing threats, security practices, and vendor dynamics. Later in this webinar, I will come back on these different categories or segments of OT security. Operation technology and information technology, IT, environments differ fundamentally in their primary functions, system characteristics, and priorities. Understanding these differences is crucial for effectively managing and securing both IT and OT environments, especially as the lines between them continue to blur in many sectors due to technology advances, or organizational demands for integrated data-driven operations. Here is a detailed breakdown of the main differences between OT and IT environments. As the definition mentioned, operational technology involves systems that are specifically designed to monitor and control physical devices and processes in industries, such as manufacturing, energy, and utilities. The primary focus of OT is to ensure operational continuity and efficiency, whereas information technology is centered around data-oriented tasks. It involves systems that support the processing, storage, and exchange of data. IT's primary focus is on managing information and ensuring data integrity, security, and accessibility. On the system design and integration, we see that OT systems are often built to last long and may run on proprietary specialized hardware and software. They are typically designed to perform a set function reliably under specific operational conditions and often involve real-time process control. IT systems generally have shorter life cycles and are more flexible, incorporating standard off-the-shelf software and hardware. These systems are designed for rapid updates and scalability to adapt to the changing business needs. If we look at the security concerns, the security in OT environments is traditionally focused on physical security and the safety of the processes. The introduction of network connectivity increases vulnerability to cyber threats, which were not a primary concern in legacy systems. This is also the reason why the OT environment was typically air-gapped from the rest of the network. Unfortunately, this air gap in most cases is no longer true. On the contrary, cybersecurity is a core component of IT. It includes data confidentiality, integrity, and availability. IT environments often implement the latest cybersecurity technology and practices to protect against data breaches and cyber attacks. The risk tolerance also has major differences. The risk tolerance in OT environments is generally low when it comes to operational downtime, and disruption in service can lead to significant safety and financial impact. Therefore, system availability, also and stability are reliable and reliability, they are paramount. While IT systems also require high reliability, there is often more flexibility to manage and recover from disruptions. Scheduled downtime for maintenance and updates are common practices in IT. Performance in OT is measured primarily by systems availability, reliability, and the safety of operations. The goal is to maintain continuous, uninterrupted system operations. In IT, performance metrics often focus on throughput, system responsiveness, and data integrity. Efficiency and upgradability are also key considerations. As already mentioned, OT is traditionally isolated, but many OT networks are now being connected to IT networks to enable remote monitoring, data analytics, and improved operational efficiency. However, this integration exposes OT systems to additional cyber risks. IT environments are inherently designed for connectivity and support high degrees of network interaction with diverse protocols and external networks. Changes in OT environments are often rigorously tested and slowly implemented due to the high stakes of impacting physical operations. Safety and process integrity are crucial. IT environments, on the other hand, typically support more dynamic change management, with frequent software updates and patches to address emerging threats and business needs. To answer the question of why OT security is a hot topic right now, let us first go back in time. It all started with the first industrial revolution in the late 18th or early 19th century. Between 1760 and 1840, mechanical production facilities with the use of water and steam power were introduced. Next to other significant advancements in the textile manufacturing, James Watt's improvement to the steam engine led to the first mechanized loom on steam in 1784. The second industrial revolution, taking place in the late 19th to early 20th century, is characterized by mass production techniques and the rise of electrical power use. In 1870, mass production powered by electricity was first introduced. During the second industrial revolution, the assembly line was invented and the industrial sector speeded up exponentially. Other major technological advancements such as the telephone, the light bulb, and internal combustion engine were introduced in this era. The third industrial revolution in the late 20th century started in 1969. The advances in computing led to machine programming, which opened the door for progressive automation. Also in 1969, the first message was sent over the ARPANET. The rise of electronics, telecommunication, and information technology, exemplified by the personal computer and the internet. It introduced the adoption of computers and automatization in production processes, leading to the advanced manufacturing technologies, including robotics and just-in-time inventory systems. This leads us to today. We are currently in the fourth industrial revolution, which began around 2010. With a focus on interconnectivity, machine learning, artificial intelligence, and real-time data, we call this Industry 4.0, also called Smart Industry. The emergence of the Internet of Things, IoT, or the Industrial Internet of Things, IIoT, smart manufacturing, and the extensive use of cyber-physical systems across various industries. Advances in technologies such as 3D printing, autonomous vehicles, and renewable energy are only a few of the technologies, to name some of which are booming nowadays. In this area of the Internet of Things and Industry 4.0, there has been a significant increase in the connectivity of OT systems, not only to IT networks, but also to the Internet. This integration enhances operational efficiency and data analysis capabilities, but also exposes traditionally isolated systems to cyber threats. OT systems control and monitor essential infrastructures like power plants, water treatment facilities, and manufacturing plants. A security breach in these systems can lead to dire consequences, including service disruptions, safety hazards, and significant economic losses. Thus, securing OT is vital for national security and public safety. Many sectors are now under stringent regulatory requirements to secure their OT environments. An example is the new agreement the European Commission reached at the end of 2023 on the terms of the Cyber Resilience Act, which aims to improve the level of cybersecurity for digital products for consumers and businesses across the EU. In short, the new regulation aims to protect all EU personnel, data, communication networks, and information systems and decision-making processes for the risk of cyber attacks. It aims to do this by establishing better internal risk management and creating a high cybersecurity standard across EU entities. In the near future, also the European Critical Entities Resilience Directive, CER, will play a crucial role for critical sectors next to the widely known NIS2 Compliance Directive, which was discussed in our previous explained session earlier this year. The threat landscape for OT environments is evolving, with more sophisticated cyber attacks specifically designed to target industrial control system, ICS, and supervisory control and data acquisition system, SCADA. Examples include ransomware attacks that can halt production lines and espionage that targets sensitive operational data. Many OT systems were designed and installed when cybersecurity was not a priority. These legacy systems often lack basic protections like authentication or encryption, and making them particularly vulnerable to attacks. Upgrading these systems with security in mind is crucial to protect against modern threats. Ensuring the continuous operation of OT systems is essential for business continuity. Cyber incidents in these systems can lead to prolonged downtimes and substantial financial losses. As a result, operations are prioritizing OT security to protect their operation against interruptions. As IT and OT systems converge, there is a need to manage and secure both environments cohesively. This convergence requires new strategies and technologies to address the unique challenges of OT security, such as real-time data monitoring and the management of both digital and physical security risks. The security of IT environments is not isolated to one's immediate infrastructure. It extends to suppliers, vendors, and third parties who can introduce vulnerabilities into the system. Addressing these vulnerabilities requires robust supply chain risk management strategies. Here you see an overview provided by Fortinet of some known attacks of the past few years with an impact for OT. In the 10 years since Stuxnet disrupted the Iranian nuclear program, we have seen a rise in sophistication and in quantity of cyber attacks on OT infrastructure. OT is particularly vulnerable as threats from the past that required a physical presence though, for example, USB file transfer, are now using the power of the combined cyber-physical environments to attack OT equipment. The cost of a breach goes up as OT is attacked. Some of the more local examples are Picanol, Stad Antwerpen, Duvel Moordgat, and so on. Productions equals revenue, and when companies are not producing, the financial implications are great. To successfully design and deploy security in any network, we need to consider the future trends and regulatory requirements while learning from the lessons from the past. Looking at what history proves, we have seen a rise in sophistication and quantity of cyber attacks on OT infrastructures. OT infrastructures or systems are and will continue to be highly desired targets for attackers. While many attacks use tools that are purpose-built to target OT systems, others target regular IT platforms and end up causing damage in OT operations by impacting systems used to monitor and control the OT platforms. This is why successfully securing OT, we also need to protect IT. But I do hope this is nothing new I'm telling you here. What is new or newer is the overview of Westland Advisory. They provided it by dividing the OT security landscape into 10 categories. Westland Advisory is an independent analysis and strategy partner for the security industry, and the 10 segments are asset visibility, network protection, network segmentation, vulnerability management, risk management, endpoint protection, secure access, threat detection, and operation and incident response. And as a last one, backup and recovery. Going into depth to each one of these is not the focus of this webinar, but do know that the vendors highlighted in yellow are part of our exclusive networks portfolio. This brings us to NIS2. As already said, NIS2 was a topic of our Q1 explained webinar, so we'll not go into detail nor make this a repetition, but you immediately see the impact NIS2 will have on OT security. The sectors in scope are all linked with OT environments, and the NIS2 security pillars can be easily linked to the previous shown different categories of OT security. Of course, people working in OT security environments are not only looking to NIS2. The IEC 62433 series of standards provides a realistic and achievable model to mitigate security risk, threats for industrial automation control systems, EIC. The IEC 62443 standard represents state-of-art in terms of industrial cybersecurity. It provides a guideline for protection of industrial control systems that the manufacturer shall implement, following the life cycle presented by the standard. The system integrator must also comply with this standard and requirements to release an adequate secured automation system to the end user, who finally will then manage the system accordingly to specific security rules. So the EEC 6243 relies on the work jointly carried out by the three actors, the manufacturer, the system integrator, and the end user. If we take a closer look to this standard or standards, they require a breakdown of your system into security zones. So rather than using one monolithic security approach for all factory or production process, security levels, SL, will be assigned to zones and conduits by using a risk assessment process. It is recommended that zone and conduit security levels be assigned based on the potential impact that a breach and the cyber risk should an attack objective be achieved within that zone. As the security level increases, the security in integrity must increase. With the security integrity, we mean the difficulty of compromising the countermeasures that can prevent or mitigate the consequence of an attack. The asset owner will demand a specific target security level, SL-T, at the system integrator, depending on what is needed for a specific zone. The system integrator, on the other hand, will define the products with the product manufacturer to achieve this security level. We then speak of the achieved security level, the SL-A. The whole idea is that the SL, so the security levels, are matched to the skill, resources, and motivation of an adversary. So you might be asking yourself at this point, where does maturity level fit and how does it relate to security level? Maturity levels are applied to processes and documents. They document how mature an organization is at carrying out a given process. Roughly, they can be described as follows. Maturity level 1, just these are ad hoc processes. Maturity level 2 are documented processes, but not necessarily repeatable. Maturity level 3 is a documented process that is rather repeatable and consistently followed. And maturity level 4 is a document process that is repeatable, consistently followed, measured, and steadily improved. But this still raises questions such as, what is the relationship between maturity level and security level? Can you build a security level 4 system using a maturity level 1 process? Can you maintain a security level 4 system using a maturity level 1 process? Well, the answer to these questions is somewhat surprising. According to the current EEC 62443 standards, there is no relationship between maturity level and security level. So you could develop and maintain a security level 4 system using a maturity level 1 process. However, it would stand to reason that the security level achieved may not measure up due to the lack of repeatable processes. For this reason, it is recommended that asset owners actively practice continuous improvement and achieve maturity levels more commensurated with the SLTs that are defined. In addition, end users are at the mercy of supply chain. For this reason, they should insist that a product supplier has work processes with a maturity level commensurated with the exceeding or commensurate with or exceeding that of the security levels of the devices that they develop. When investigating an OT design, you will always come across the Purdue model. Purdue is a university in the US. In the 1990s, they came up with the PARA, Purdue Enterprise Reference Architecture. It is basically a guideline with a reference to how to segment your ICS network. As the arrows indicate, only the simplified, this is only the simplified outline, not all levels are allowed to talk to each other, where the EAC 62443 focuses on securing communication channels and minimizing the attack surface and implementing strong access controls to protect against cyber threats. The Purdue model primarily emphasizes functional separation to prevent interference between the different levels of the hierarchy. Here you see in more detail an overview of the Purdue model with the different levels. I will try to explain it as simple as possible. Let me have, I don't have a drink. 1 second. Yeah. Level 0 are the physical components that actually build products, being the sensors, the actuators, the valves, the pumps, and other devices directly interacting with and monitoring the real world process. Level 1 is composed of systems that monitor and send commands to the devices at level 0. Examples include programmable logical controllers, PLCs, remote terminal units, RTUs, and intelligence electronic devices, or EADs. At the level 2, there are devices that control the overall processes within the system. For example, the human interface, HMAs, SCADA software, which enable humans to monitor and manage the operational process. Level 3 supports management of production workflows, Examples include batch management, manufacturing operation management, and manufacturing execution systems, MOMS or MES, and data historians. Then we have level 3.5, which is the demilitarized zone, DMZ, as a sublayer between OT, the layer 0 up until layer 3, and IT layer 4 and above. Level 3.5 is typically created with the help of firewalls, and in industrial DMZ zone, IDMZ, it creates a barrier between the IT and the OT networks. Solutions like jump boxes can provide limited access to the ICS systems from IT environments, but this buffer can also help to prevent infections within IT environments from spreading to OT systems and vice versa. At level 4, systems like ERP, planning software, databases, email servers, and other systems are placed. And then level 5 are more the IT network and even the internet if you want to. Another good starting point for oh, sorry, I missed some information. Let me go back. I wanted to tell you. Yeah, the advantage of the Purdue model is its hierarchy. System components are clearly defined, and components are grouped into distinct layers. Borders between the layers are logical places for network segmentation to control access between the layers. The model may not exactly fit your OT networks, but it's still a good starting point for securing an OT network. Another starting point is the NIST cybersecurity framework. We also know from IT cybersecurity. We all know the different steps of first identifying, then protecting to be able to detect threats and respond to them adequately in order of being able to recover from a potential attack. If we would map the different blocks of this framework to OT security, we would get something like the following. As very good presented by the following graph. On the left, we see the NIST categories and how they help to create a layered defense. Evolving over time from right to left, going from first creating an inventory of the to be secured assets and processes towards completely pre-made playbooks and behavioral anomaly detection. So going from left to right, the security maturity will also improve, as also often the complexity and time consumption to implement those security will rise. So to wrap up this session, I would like to give you some key takeaways. Start discussing with your customer. If they have an operations environment, do not limit your interactions with IT, only with IT. Start discussing. Do not be afraid to tackle OT security. At the moment, only OT manufacturers are talking about OT security, and by definition, they are no cybersecurity specialists. So you have certainly a value to add. IT is not OT. We have seen the main differences, but also the people you will need to talk to will be different. It will not be the IT manager who will need to be convinced, but often the plant or operation managers, sometimes even the facilities or quality responsible person who will have a total other agenda and mindset than the people you are used to talk to. And then, of course, remember, IT breaches cost money, OT breaches can cost life. So this will end up our webinar. I want to thank you for your attention and hope to see you back in one of our next sessions. Maybe if you want to learn something more into depth about OT security, please, you are more than welcome to subscribe and attend our Fortinet Nozomi webinar on the 11th of June. We will explore the integration and enhancements of Nozomi networks and Fortinet within the operational technology landscape, and I do hope to see you there. Thank you very much and have a nice afternoon. Bye.